Hey everyone, we have already seen the intuitive way to solve today's GFG problem of the day, that is swap nibbles in a given byte. Okay, now let's look at a smarter way. Let's look at a very optimized way. But let me clarify. If you haven't watched the intuitive way first, I'll highly recommend you to go and watch that video because it will help in building the intuition. Now for this smarter way, you need to be very good or you need to have very clear understanding of basics of bit manipulation and in particular four operations. Which four operation? First one will be your left shift operator. Okay, first one is left shift, second one right shift, second one is right shift. After that, bitwise or that is represented by a single pipeline, and fourth one is bitwise and. If you have clear understanding of these four operators, you will be able to implement this solution very easily. You will be able to understand this solution very clearly. Let's have a quick look. At each of these operations. Okay, so let's see what is left shift. Left shift, what it does is move your number by the specified amount. What I mean by this, let's take an example. Let's say we have a number called 7. Let's take 7 for example. For all of these four operations, we'll be using 7 for all these four operations for our understanding. Okay, so let's say we have 7 whose binary representation is 1 1 1. Now if we implement left shift on this, let's say we write 7 left shift by 1. What it will do is move all the bits by one place. So resulting number will be 110. In decimal equivalent, it will be equal to multiplying a number by 2. Okay, if you do a left shift, so by the number you do left shift, you multiply it by that number of 2 to the power. So if we are doing 7 left shift 2 in decimal, 7 left shift 2 in decimal, it is equal to 7 multiplied by 2 to the power 2. Okay, so this is what left shift will do. What it will do, it will shift the number, the bits of the number by given input. Okay, this was left shift. Now let's understand what is right shift. Similar to left shift, right shift also does the operation but in opposite direction. So if I write 7 left shift 1, what it will do is move all the bits by 1 to the right. So 7 was initially 1 1 1, right, in decimal equivalent. It will transform to 0 1 1. Where this 0 came from? From filling the empty space. Okay, so this one will be moved out of the window and these two ones will move backwards. Okay, in decimal it is equivalent to dividing a number by 2, integer division by 2. So for example, if it was 101, which is equivalent to 5, it will convert to 010, which is equal to 2. So 5 by 2 decimal division will also give you 2, right? So right shift is equivalent to dividing by 2. Left shift was multiplying by 2, right shift dividing by 2. Now comes the remaining two operations, that is bitwise OR and bitwise AND. Okay, so bitwise OR and bitwise AND is pretty straightforward. What bitwise OR will do is it will take two numbers, two binary representation, and wherever, if either one of a 1 has a particular bit, it will set that to 1. For example, if your first number is 5 101 and second number, let's say, is 6 110, so resulting will be for bitwise OR, resulting will be this has a 1, so 1 1, and both has 1, so 1. For other example, if it was 0 0 here, so this would have been set to 0. This is what bitwise OR is. Simply set 1 if either of the number has 1 at that bit. Okay, now similarly, what will be bitwise AND? Bitwise AND will set 1 only if both of the place has 1. Okay, so here both were 0, so we'll set 0. Here this number or this bit was 0, right? In the second number this bit was 0, so we will set 0 here. Now here your first number has bit as 0, so we'll set our answer as 0 over here. And at this place both of the numbers have 1 as the bit, right? Both of the bits are set. So in our resulting number, this bit will be set. This is what bitwise AND is. Now, how can we use these four operations? How can we use these four operations we learned just now to solve our problem? Okay. So what is our aim? Our aim is to extract these two 4 bits, that is a nibble, separately, and you have to somehow integrate them back, right? That's our main goal, what we did in intuitive approach also. So if I do this for extracting, let's say first we try to extract this part, the first part, what can we do? Can't we use right shift? Right now we learned if you use right shift, it shifts the bits by a specific amount, right? If you are doing right shift by 1, it will shift by 1. If you do by 2, it will shift by 2. So if we apply right shift by 4 on this number, won't this change to 0, 0, 0 and then 0, 1, 0? From where these zeros are coming? These zeros are coming by filling of 8 bits number. What I mean is when you will apply a right shift of 4 on this number, this will become, these 4 places will shift to right, that is 0, 1, 0, and since we are representing our number in 8 bit, remaining bits will be filled by 0. Okay, so we are able to extract the first 4 bits or the first nibble. What we have to do is we have to write and right shift 4. Okay, this is how we will extract this part. This part will be extracted in this way. Now, how can we extract the second nibble, that is this part? We need to get this part of the number. For getting this part, if you simply apply left shift, what will happen? If you simply apply left shift, remember left shift multiplies by 2 or shifts whole bits to a given number, given input. So if we simply apply left shift by 4, what it will do is it will shift whole number by 4. So you will have 0, 1, 0, 0 and then 0, 1, 0, 0 and then 4 zeros at the end. It won't only shift this bit, but it will also shift the first part as well. Your whole number will increase. Now we know we just have to extract the last bit. So if we are able to set all these bits as 0, all the first 4 bits as 0, and then if we shift this part, won't we get our required number? So if we do this, what will happen is, first if we set these 4 bits to 0, from here our number will change to, if we set the first 4 bit as 0, our number will change to 0, 0, 0 and then remaining last 4 bit. Now if we apply a left shift on this, this will convert to 0, 1, 0, 0 and last 4 bit will be 0, which we don't mind. Our the second part of the nibble has shifted forward, right? Our second part of the nibble has shifted forward, which is also required state in answer, correct? So if we do that, we'll get the second part. We'll be able to extract second part. Now, how we will set these 4 bits as 0? How we will set this 4 bit as 0? So remember we talked about something as bitwise AND. We can use that. How? Let's create a number in which these 4 bits are 0 and this bit is 1. Okay, these first 4 bits are 0 and remaining bits are 1. So what will be that number? Our number will be 0, 0, 0. First 4 bit are 0 and then remaining are 1. Okay, remaining are 1. Now if we do AND with this number, we AND our input, what we will get? That is 100 over here. So if we AND 0, 1, 0, 0, 1, 0, 0, what we will get as output? We'll only get those bits set which are 1 in both of them. And since our last 4 bits are set, therefore we'll only get those bits set in the output which are set in the input. Makes sense, right? Try to understand clearly. Here all the 4 bits are set, and since all the 4 bits are set and we are doing binary AND, our output will have only those bits set which are set in input. Okay, and for these bits, for the forward bit, since we are already making them as 0, therefore whatever is in input for them, our first 4 bit will be set to 0. It is all possible because of bitwise AND. I hope it makes sense. If it is not, just go back 2-3 minutes back and you will be able to understand pretty clearly. Because of 0, our first 4 bit will always be set to 0, and because of these 4 ones, our bits will only those bits will be set which are set in input. Okay, so what will be the output of this? The output of this will be 0 0 1 0, and remaining first 4 bit will be set to 0. Okay, now if we apply left shift of 4 on this number, what we will get? Our number will shift by 4. Like these 0 will move out of window, because zeros on most significant bit doesn't make sense, right? So this 0 will move out of the window, you can say, and last 4 bit will be set to 0. Last 4 bit will be set to 0. Also, before I forget to mention what this number will represent in decimal equivalence. This number will be equal to 15. You can calculate for yourself, but this number will be equal to decimal representation of 15. Okay, so if we have to do bitwise OR, we will do our n, the given input, bitwise OR with 15. This is what this operation is. This is what this operation is. Okay, n bitwise AND with 15. Now what we have done here is n bitwise AND 15, and then we have shifted it to left by 4 places. Okay, so this is what this number is. Now, is there a way in which we can combine our first and second number together to get the output? I say there is a way. There is a way how we can combine these two to get our output. So if you see clearly, our number from second operation is 0 1 0 0. The last 4 bit have shifted forward and remaining are 0. Okay, and from this operation, our input was our output was the first 4 bit shifted backward and the front was 0, so it changed to 0 0 0, and the first 4 bit were 0 1 1 0. Now if we do a bitwise OR of these two, what will happen? If any of the bit was set in either of the number, it will set in the output as well, right? So this will change to 0, this will change to 1 1 0, and 0 0 1 0. And isn't this the output? Your this 4 bits have shifted to the back and the last 4 bits have shifted to the front, right? Your first shifted to back and last shifted to front, right? This is what we wanted. So how can we write this operation? It is simple. First part will be this part, first part will be this part, this one, and second part will be this part. So if you return a number that is bitwise AND of n and 15 shifted by 4, and then you do a bitwise OR with n right shift 4, you will get your answer, isn't it? You will get your answer. So let's try to write this simple single line and let's see if we are able to get our answer or not. Okay, so let's move to the code. So we have been given an input n, and we'll simply do return of first operand, that is n bitwise AND of 15, and then you will left shift it 4, and then you will do a bitwise OR with n right shift 4. You will just enclose it in parentheses, put a semicolon there, and I think this should work. So sample test case passed. Let's submit it. And yeah, we are getting the answer. Our answer is successful. So this is the simple approach, a single line approach for solving this problem. Again, if you're not able to come up with it, nothing to worry about. You can always go with the intuitive approach. That was also big of fun, but this is a smarter way of doing it. So that will be all for this video. See you in the next one. Thank you.